Hey guys, welcome back to the video. This is an extension of simulation 1, and in this video we are going to learn about how to establish communication between robot 1 and robot 2. Alright, in the simulation 1, the previous video, I did not speak much about establishing a communication between these two robots. I just told you guys how I just walked through writing a program or a simulation program and not using a communication protocol. We just used a wait command for robot 1 to wait, sorry, for robot 2 to wait until robot 1's code was executed, and once the timer was clocked in, the robot 2 executed. So usually we don't, in the industry, they don't practice this kind of coding style. So which is very unsafe. If the timer fails, it can cause a disaster. So what we usually do is we use something called as a digital input and digital output to communicate between these two robots. So now, very important thing is we have written codes right now using simulation program, like for the in the simulation one, and like if you have watched it in the previous video. So here what I'm going to do is I'm going to create a new program using teach pendant. I'm going to program everything using teach pendant. So I am not going to explain each and every line as per how I did in the previous video, because I'm pretty sure you guys are aware how to teach a user frame, to teach a tool frame, and how to teach different points and everything. I'm just going to walk through the line of codes I have just written, and I'm going to emphasize more. So this video is going to be very specific on establishing communication. So I'm not going to keep it very long. So here we're only going to concentrate on how to establish communication. So it's very easy, to be honest. There's nothing much to do. So I'll try to wrap up as early as possible and also keep this video short with you guys understanding everything in detail. So first thing first, what I do is I have to teach couple of position registers. Okay, so I go to type okay, so how the teach pendant opens, I didn't tell you that, guys. So what you do is you click on write, you click on add TP program. When you hit add TP program, so you can add a teach pendant program in your robot. So what is this small screen with a robot symbol means is it is a simulation program. The simulation program is basically like this, it is just the way the last time how we coded was a simulation type of program. So here we are going to use a teach pendant program. So teach pendant program, first thing first, we open teach pendant. So teach pendant is like this. You can also use a teach pendant from here. So each robot has a different teach pendant, right? Obviously they have to have a different teach pendant. So this one in our simulation, in this particular video, this one is called robot 1 and this one is called robot 2. Okay, so we can also switch between robot 1 and 2 using this option over here. You see, robot controller 1, robot controller 2, very simple. So what we'll do is let's go to robot controller 1 first. Okay, in robot controller 1, so what I have done here is I use a lot of functions. I have a habit of using a lot of functions. So it's up to you, your coding style, your understanding, your feasibility to create a program, on how good you are and how fast you can do. So it is up to your style. So you don't have to follow the way how I did it. So what I have done is I have created three functions. So one is I have written, so you can see under the program task list over here in the left hand side, I have a teach pendant program for drop. You can see this teach pendant symbol over here. Yep, I have a program that is main. So this is my main program, and these are all my sub programs which I've written. And this is a pickup sub program. This is a drop sub program. All right. So I'll go to my pickup sub program first. Let's start. Okay, let's go to main first, right? Let me show you the structure of main. So I will not focus on line number 5 and 6, the DOs now. I will talk about it soon. Alright, first let me cover up the basics, what I have written in the code, so you guys don't get confused. So this is a very very nice way to start the code with tool frame number and user frame number. You guys are aware of it. I'm not going to talk about DOs now. I'm going to talk about it in a bit. So I'm going to set a home position using a position register, you will soon see where the home position is. And I'm going to use a call function, right? A call function, I'm going to call pickup prog. Then I have two intermediate points. You can see here how it's kind of lighting up. And I have a drop position, my pickup position, a drop position, home position, back to home. And there is one more DO over here, so which I'll talk about in a bit. So all you have to know in this particular section is I have used call function. How do you use call? Where do you find call? Very simple. Let me see if I can increase the size of the teach panel a little so that it's visible for you guys. So, right. Okay, good. So how do you find call? So very simple, go to instruction and you find call here. That's it, right? You don't have to, not a big thing. So now let me go to my pickup program. Hit select. Line number 20 pickup prog. That's my pickup program, right? I have a tool frame number, I have a user frame number, I have a variable called PR offset. Do you know what is this? This is I comma j. Again, I have used position register number 2 and have set an offset for 300. I've commented this as tool offset. That's why it's showing tool offset. And 3 indicates in Z axis. You know 1, 2 is X axis is 1, 2 is Y axis and 3 Z axis. So I want the offset of Z axis. That is when from the point where I have my pickup position or drop position, I want an offset of 300. So how do I say offset of 300? I call PR 2 comma 3, right? So that is how it works. So PR3 is pickup for the pickup position, right? I've used an offset. So okay, this is to move the part above the pickup position, not to the pickup position. So now here is a very important catch. Okay, so okay, so PR3 is pickup position. Pickup position is where it goes and touches the pickup position. So it's not picking up at that point, it has reached that position, and the right next line would be to put on the DO, like how you guys do it in the FANUC robot and the labs, right? You guys put on the DO, the vacuum turns on, or the gripper closes or opens, depending on what you guys want to do at that moment. So this is that position where you after this line you have to put on your DO. Okay. So here in Roboguide, we don't have that feature of putting on the DO, right? Right now what we are doing here is, now understand the difference, right? Very important. Please understand the difference. The difference here is we are writing a code on a teach pendant in this session. In the previous session, we wrote the code on a simulation program. Usually, a simulation program is easy to write a code. We don't have to do much. We just have to create a couple of lines, keep pressing lines, new lines, and you just have to teach different points and by randomly moving the robot up and down. But here you have to. This is the same way how you guys are going to play around with the robot, like an actual robot. So I would say stick to your practice of creating lines of code using this fashion. So I just did the previous video just to give you a brief about how to give an introduction. So you must be familiar with using a teach pendant. So please follow these steps. So I was talking about DO. So in Roboguide, you cannot put on a DO directly, just like that. So what we do to pick up a position, this is a simulation. So this works on all geometry. So what we do is to pick up, just for this one line of code, just to pick up like this particular part, just to pick up the part like a DO, like a vacuum suction, putting it on, or gripper closing itself to hold the part tightly. So for that case, what we do is we create a simulation program. We create a simulation program just for one line of code. Nothing else. There's nothing else in that. Please understand, there is nothing else in that. It's just one line of code. Okay. So this is the call pickup robot underscore 1, pickup underscore robot underscore 1, this one. So this is my simulation program, just one line of code, picking it up from part 1 from the pick fixture using this particular end of arm tooling, right? Just one line of code, that's it. Don't do anything, close this, because we have no option in Roboguide to put on DOs over here, right? That is the reason we make use of a simulation. So make sure, so how the teach pendant takes is whatever symbols you can see, the teach pendant symbol, let it be, or even do a robot with a small box over here. So these are all programs. The controller understands these are all small programs. So you can call these programs at any point of time, anywhere, using the call function on the robot, on the teach pendant, right? So the same thing, I have called this function, I've used a call function, and I have used this code pickup robot underscore robot underscore one. Now what is pickup underscore robot underscore one? It is my DO, basically, to put it on. So that point of time, at that place, it will lift the part, right? So now the DO is engaged. I mean, it's like the pickup simulation is on. I mean, the part is on the robot's end effector. I mean, end of arm tooling. Lot of different synonyms for that term. Anyways, so it moves further. After picking it up, there is a tool offset for 20 mm above, like I gave. Like I told you guys, I just want to move the tool right above my part. So that is the reason I've given it as tool offset. This is the robot pickup program, right? This is one of the sub programs that is called in the main program. Don't get confused. Main program calls the pickup program first. In the pickup program, we again call one more simulation program called pickup robot 1, and that simulation program is here. Okay, I hope that's clear. If it's not clear, please watch this small part of the video again until you understand. I hope I've made myself clear. So this is very simple. This is done. Pickup is done. Now let's go to drop, right? So now let's go to main. In main we have done pickup. Now there is drop. So we go to drop prog, right? Drop prog is my sub program that is being called in the main program. Again, drop underscore prog is being called in the main program. All right. So same way, tool frame, view frame, same thing. I've just copied this. I've simply copied the pickup program to the drop program, but I've just changed some points. There I had PR position register 3 to pick up. Here I have position register 4 to drop. All right. So what is this position register 4? This is the drop position. It is not DO. It is the drop position. At position where the one line before putting on the DO. If it makes sense to you guys. I hope I'm making sense. Say you're taking your arm extremely close to the closest position where the moment you put on the DO, the part has to come on the robot's hand. So that is this position. That is position register. But this is a drop position. Okay, this is a place to drop. That was pickup. So okay. Now same thing. There how we had pickup. Here we have drop. I'm sorry for the wrong comment here. So it's simulation drop because I just copy pasted the program, so I'm not going to talk much on that. So yeah, so it is so what we have to do, we call the drop robot 1. Now same thing like how we did for pickup robot 1. What was pickup robot 1? Pickup underscore robot underscore 1. What was it? It was a simulation program. The simulation program was created just for one line, that is to pick. Same way we are creating one more simulation program to drop, right? Very clear about it. Be very clear about this step. Don't miss this step, else you will get confused. We are using this step because we have to create pick and drop functionalities at that point, right? So we create these two small simulation programs. In the drop, same thing. We use part 1. We have end of arm tooling, and we have a place point, right? This is it. You select this. You have done with the you're done with the coding. That's it. Now same thing for the other robot. Okay, don't have to worry much. It's the same thing. I've copied the same code. This is a clone robot. You would know what is a clone robot in the last video, how I created. I've just created a clone from this. How do you create a clone? You click on robot controller, right click on it, and you say add robot clone. It creates a clone, and you guys are aware how I changed the end effector over here, how I have used a vacuum gripper, how I've selected what are the options. Please look at simulation 1 for all these understandings. Okay, this video is totally to emphasize on robot connections. Everything is the same thing I've done, like how have followed up in the simulation 1. The only difference is a coding part here. Okay, so don't get confused. The coding part is what I'm explaining it to you guys very clearly, so please try to understand and pay attention. So now we have explained the coding for robot 1. Robot 2 also has the same structure. How do you see robot 2's structure? you have controller 2 here, robot controller 2, and the programs also the same thing. I have something called as pickup. Now there's a pickup program, right? There's I can show you the main code once. Let's start with main. I'm gonna come back to the DOs and DIs, so don't get confused about it. Let's start with line number 8, tool frame number, U frame number, position register. I have a pickup program. So these are some intermediate points what I've taught. You don't have to really worry much about it. You can teach intermediate points. Intermediate points are basically if you want to reach location A and location A to B, I'm teaching one intermediate point, say A by 2 or something like if I want to reach A to C, I'm teaching an intermediate position B so that it can easily go and touch C without much complications. I'm calling a drop program as well, same way, and that's it, right? The function here is to pick up and drop, that's it. So let's not make things very complicated. Same way, pickup program, it's very simple, just like last line, just like the previous code what I had written. Here also you use two simulation type program types. One is to pick up the part, this is pick, and this is to drop. Okay, so here you would see I have drop named here, but I have picked here. I have picked the part here. So what is happening here? This is a pick fixture, right? Remember now what is this? What is our aim of this experiment or this simulation? Robot one, where let's see. Okay, this is my pick fixture. Blue is the pick fixture. Robot 1 picks the part from the blue, drops the part to the place. Robot 2 picks the part from the place. So it picks the part from the place and drops it to the pick. So drops the part to the pick fixture. Right? What is pick fixture? Blue color. So I need to write drop the part on pick. So that is why I have changed this. So that is the only change. In the pickup I have done. Okay, I think yeah. In the pickup what it is? Pick up the part from the place. This is a place fixture, right? So picking up the part from the place. I hope this is clear. So I'm going to now I'm going to start with the digital input and output connection. This concept is very important. You can use this concept to establish communications between two robots. You don't have to use wait command after you know this particular if you get this idea, right? I'm going to keep the teach pendant aside. First things first, click on cell, click on IO interconnections. Okay, you clicked on IO interconnections, right? What you have to do, click on add couple of digital input outputs, right? So I have added already 4 of them. You can add only 2 if you want to, because you're going to use this just for 2 robots, then 2 is more than enough. But if you want more than that, you can. Now let me explain you how this works. What is the story behind this entire thing? What is this work cell input output? What is this? So this is the way of communicating the robot in its language. So basically what we are going to do is we are going to tell robot 1 in very layman's language. I'm going to explain it to you in a very nice way, in a very easy way. Robot 1 has to tell hi or hey to robot 2, right? This is how it communicates. It says hey. So the goal for us is what do we need in this simulation? Let's understand what is our need first, and then let's jump to the solution for it, right? So robot 1 first picks up the part from the pick fixture, places it in the place fixture, goes back to the home position. Then we need it to say, hey robot 2, I am happy with my home position, I am done with my job, I have picked up the part, I have dropped the part, I have reached home, and I am set, I am done with my job. Now it's your turn to do your job. So this is what robot 1 has to tell robot 2. So robot 2 is like, okay, I'm going to start doing my job now, and that is when robot 2 starts working, right? Because robot 1 is halted now, because robot 1 knows that robot 2 is working and I should not move. And robot 2 then tells robot 1 that, hey, I'm done with my job as well. So now it's your turn to do the job. Does that make sense? Okay, I hope it makes sense. So that's the whole story over here. So there is robot controller 1, that is robot 1's controller, right? It's got a digital output and it's got a digital input. Okay, so what we are going to do is The digital output, the start points are basically, they're like position register numbers, like 1, 2, 3, 4. You can go up to, like, certain number of digital input and output. So these are start points. So don't get confused between the type of what do you say, basically they're like index, like 1, 2, 3. So you don't have to get confused with that. So what's happening is robot controller 1 has to give a digital output to robot controller 2's digital input. So output is communicating to the input. Make sense? Output is communicating to the input. Same way, input is also communicating to the output. So this is like interconnected, like it's like a loop, it's interconnected. So we have just establishing nodes here, like say DO1 of robot controller 1 is connecting to the DI of robot controller 2. We cannot connect DO1 to DO of 2. So I mean, DO of robot controller 1 cannot connect to robot controller's DO. It has to be connected to the DI. Very important. Please understand this. Okay. Outputs are connected to the inputs and inputs are connected to the outputs. So in the same way, robot controller 2 communicates with robot controller 1's DI. Same thing. So this is redundant. These two are repeated again. So don't get confused. We just need one set of pair. I mean one pair of DODIs. So I hope this is clear. 1 wants to communicate with 2, so 1's output will say hi to the 2's input, or 2's output will say hi to the 1's input. So output says hi to the input. Okay, input doesn't say hi to the output, right? So this is how it works here. Okay, so always remember like that. This is a way of remembering it, so that's why I'm giving you a small hint so that you can figure this out. You hit apply, you hit OK. You don't touch anything right now over here. Next thing, come back to the code now. Now I'll tell you what is happening here. Now let's go back to my robot controller 1's main program. So we have line number 5, line number 6. So what I'm saying, I want them to be off. Even if it's on, I'm forcing it off because I'm starting my code. I start my code with the main program, right? My entire simulation's first starting program is main of robot controller 1. Please understand this. Okay. This code starts, this code begins, uFrame 1, uTool 1. I mean to say main of both the controllers, not just controller 1. Main of controller 1 and main of controller 2 starts at the same time. I'll tell you how it works now. Just pay attention. This is a very crucial part. So line number 5 and line number 6, we are forcing all the DOs to be off. Okay, these are the comments what I gave, just like how I explained it to you right now. The same way, just for me to remember, I just gave a small remark, so don't worry much about that. Just concentrate on the concept that I told you. So please remember it in that way. So line number 5, 6, forcing it off. This is home position, like I said. We're not going to talk much about it now. Very important. Digital output of robot 1 when it is on, then digital input of robot 2 automatically gets on. The story is clear by the story what I told you a minute or 2 minutes back. So we are putting the digital output of robot 1 on at the end at line number 17. At 5 it was off, 6 it was off. Now at line number 17 it's turned on. What happens when it turns on? The moment it turns on, I mean, don't worry much about the code with call. All of this happens. The robot moves to pick. It does its job. It goes to home, drops the part, comes home and says, hey to robot 2. The part of saying hey to robot 2 is line number 17. You get that? Line number 17 is a communication protocol where hey comes to robot 2. So robot 2 is, now let's go to robot 2's main, right? Let's see what robot 2's main got. So robot 2 says have jump labels, couple of jump labels here and there. So pay attention. So let's not concentrate on jump label first. First, if condition. If my DI is on, when my DI of robot 2 will come on, when the DO of robot 1 will come on. Make sense? Right? DO of robot 1 comes on, DI of robot 2 automatically comes on, and if my DI of robot 2 comes on, I will jump label, I'll go to label 2 and start my code from here. From line number 7, zip, I'll just go all the way down. Good. And that's the basic logic what I used here. So this is very simple. You don't have to think much in this. It's very simple. If DI of 1 is on, that means robot has sent hi, or already is like told, I already given him robot 2 a message that its job is done. And from there, from label to UFrame number, tool frame number, all this call and all that, pickup drop. Yep. It's the same continuation, right? Now, why label 1 here? What happens if the DI is off? When is DI off? When DO is off. DO of robot, I'm being very specific with the terms and terminologies here, so please pay attention to my wordings. When the digital output of robot 1 is off, the digital input of robot 2 also is off. When the digital output of robot 1 is on, the digital input of robot 2 is also on. So if robot 2's digital input is on, start the program of picking up the part from the place fixture and dropping the part to the pick fixture. I hope this is very clear, right? So okay, we had a small lag there. Okay, anyways, so now we have jump label 1 and label 1. Why is this? We are putting this in an infinite loop. Okay, I am putting this in an infinite loop, line number 1 to 3, because main program runs simultaneously to the main program of robot controller 1. The main program of robot controller 2 runs simultaneously with the main program of the robot controller 1. And when it runs simultaneously, if this DI is off, again, when the DI is off, the DO of robot 1 is off, the DI of robot 2 is off, it keeps looking until when the DI is on. It will keep running around this loop, like label 1 goes to label 1, it checks if it is off, it will jump label 1, again label 1, jump label 1, it will keep going. That's the whole logic of having this thing here. There's nothing big rocket science. That's all. And this is what I had to tell you guys, that try making use of digital input and digital outputs for the simulation if possible. It will help you guys understand how it works, and really it's a nice feeling to learn it. So if I hit right now, what I'm going to do is I'm going to hit on main and I'm going to hit start. So my robot 1 goes, picks the box, goes back to home position. Okay, let's give you guys better explanation, right? Okay, so home position, goes offset position, pickup position, DO is on, offset home, drop, offset, drop, home position, and says hi. Robot 2 says okay, picks up, home, drops, offset. Okay, so I did not disable the part here, so this is always an issue. So what you can do is robot 2, always turn this off when you're starting the simulation, always. Right, so this is all about this video, guys. Thank you so much for your attention, and all I had to tell you is this is how it works. If you have any doubts, any type of doubts, please try to reach me out. My name is Dunstan D'Souza. I am the teaching assistant for the course Real-Time Robotics and Robotic Vision System. So please feel free to get in touch with me if you have any doubts. Thank you so much. Bye bye.